So we're going to shift gears here and we're going to talk about modeling. So we've got another, say, 20, 25 minutes or so, and then we're going to open it up to Q&A, but there's a ton of stuff actually to talk about on the modeling front. So again, I've already introduced myself at the beginning, but if you came in late, my name is Stephen Roselle. I'm a product manager on the Maya team, and I just realized my video is not going, so here I am. I've been working on the Maya team for quite a while now. I'm working with Maya for quite a while now, and I've been working across Maya in different aspects, but I have a particular interest in modeling, so I'm going to cover that for the next bit. So we have some cool new stuff to show. One is just a really great new feature that's one of the most common feature requests we get on the modeling side over the last many years. And then something brand new to Maya called Create VR for Maya, which is a VR application, a fully immersive VR application for doing sketching and building up of geometry for kind of design and concepting. And I'll talk more about that. We'll get into some more granular features. There's a lot of kind of lower level, kind of nuts and bolts type features, I like to call them, on the modeling front, which we'll get into. So we'll start with Sweep Mesh. Sweep Mesh is a great new tool. It's a lot of fun to work with. I think for the modelers out there, you're really going to appreciate this. It's something that it has been needed in Maya for a while, and that is basically just a one-click solution for converting curves into geometry. So here you see I take a curve, convert it to geometry, and then I've got all these sliders, all these bells and whistles for controlling the output of that geometry. So you can change the profile. You can have it a circle or a square or a line or an arc. You could set this to be a wave pattern, or you can even do instances, or what we're calling elements, basically similar to mask, where you're repeating a pattern, in that case, spiraling to create a coil. You can create custom curves for the profile itself, either use the pre-built ones or the custom curves. So you can create things like architectural details and crown molding and get really, really fine control over the shape of that extrusion. So it's, again, one-click solution. It's one node that has all this stuff built into it. It's super intuitive. It's really, really fast to iterate on. You don't set a lot of options up front. You just click apply, and then you just start going to town, tweaking the options. It replaces the old legacy NURBS workflow. So the legacy NURBS workflow has been around for a while. It's still there. You can use it, but as a lot of modelers know, it can be a bit cumbersome for creating this kind of mesh in particular. One of the things was this NURBS tessellate node. Without going into too much details, it was really complicated and unintuitive and hard to use. So this no longer requires any of that. You're not using NURBS at all. You're just going directly to polygons, which is the more common use case. And like I mentioned before, you don't need profile curves. So you can actually just use some of these presets, which you see up here, like these preset shapes with a lot of procedural attributes associated with them. Performance is actually very good as well. It scales linearly. So you can create one sweep mesh, or you can create 100 and then have that node control all 100 of those. And it accepts multiple input curves. So you can have one node per curve, or you can have one shared node for all the curves so that they all be uniform and consistent. So it's pretty flexible in that regard. And the problems it's solving here really have to do with the quality and the results, not just the ease of use, but the actual quality of the results. So you can see here what would happen with some of the old NURBS workflows, where it just really didn't handle things very well. So one example is hard edges or corners or right angles, linear 1-degree curves. The old extrude tool just didn't know what to do with those, as you can see from this image, and also volume preservation. So when it comes to actually creating pipes, for instance, you want to have a uniform volume across that. You want proper edge orientation when you're doing the elbow bends. The old extrude tool just, again, didn't really handle that. The new sweep handles it quite well. It also handles density quite well, so it does a smart topology. So it only adds detail where you need it. And it's used for lots of different shapes. So I mentioned earlier on, this is kind of a Swiss Army knife type tool where you can just create all these different shapes. It's not just tubes. It's not just robes. It's pipes, it's spirals, it's coils, it's twisted cables, it's architectural detail, crown molding, corrugation, muscle shapes, hair cards, you name it. You can create all kinds of different things with this. So I'm going to do a demo now. I'm actually just going to let this play, but I want to do a quick plug to an artist that we collaborated with. His name is Roy Bennett. He created this awesome kind of sci-fi futuristic car garage scene, and he was kind enough to let us use it for the demonstration. So I want to give him a plug. You can go to roybennett.artstation.com if you want to check out his work. Really talented guy, avid Maya user, of course. So I'm going to pause my talking, and I'm going to let the video play. The new Sweep Mesh tool in Maya 2022 is a really versatile curve-based modeling tool. Basically, works with NURBS or Bezier curves, allows you to select curves and then just in one click, quickly create a mesh. So most common example would be, of course, tubes and wires. But you can create different shapes based on these different profile presets. So we have the ability to create rectangles with rounded corners. You can control things like the width and the height. Obviously, you can control things like the subdivisions along the length. But it also does a really good job of dealing with things like elbows and things like corners, which the old NURB surface tool just could not handle. So what you'll see here is we're creating a pipe, and it maintains the constant volume all the way through the length of the pipe, including the elbows. So it creates really nice elbows. So I could basically select these and extrude them and get essentially like what looks like an actual plumbing elbow in a pipe. Similarly here, we can take a edge around a shape and create kind of frames and architectural details, so something like crown molding. And you can customize that using a number of different methods. So you can use a simple polygon shape and then define that shape as your profile. And the perimeter of the plane in this case, or it could be any arbitrary shape, but the perimeter will define the profile of that extruded or that swept path. Then you can go in and interactively adjust that. So as you change the shape of the profile input, that will change the shape of the actual sweep mesh. And you can also do this on top of other surfaces or on top of other geometry. So here we're basically taking some edge loops on the fender of this car. We're converting those to curves. We're just doing a quick combine to turn that into one curve. And then we're creating a sweep, which by default is just going to be a simple circle. We'll tweak the divisions here a little bit. And then we'll actually use another edge loop from another piece of geometry as the profile. So we're using one edge loop from one piece of geometry as a profile, another edge loop from another piece of geometry as the path, and we're basically able to construct geometry on geometry with sweep. So here's another example of that. We're basically taking the edge loop around the collar of this character, this piece of armor, and we're going to sweep that. And by default, we'll get a tube. We can switch that to a line or to an arc. We have these other cool pattern tools like wave. You can control the alignment, so you can basically say align to the left or to the right or to the top or the bottom, and then you can expand out from that. Here we're creating cycles in the wave, tweaking the amplitude, tweaking the orientation, and then now it looks like we basically have kind of a beveled extension of that piece of geometry. And then lastly, we can create instances or patterns. So we're using the distribution feature here to basically create instances of tubes or any profile shape, and then repeating that in a pattern, a circle or square or linear pattern. And then we're tweaking things like the twist, and the twist is going to give us coils basically. So a wound cable, something like you would see on a suspension bridge. And we can also change the taper. So the taper can just taper uniformly or linearly rather, or we can use this nice profile, this curve widget to define the taper. So as you can see, Sweep is a really versatile tool for creating lots of different shapes. All right. So
The news.
moving on, we're going to talk about something completely different, and that is Create VR from Maya. You may have seen a couple of teaser videos by now showing this off. It's an immersive conceptual design tool application that is it's kind of like a sidecar application to Maya. So it doesn't actually ship or bundle with the installer for Maya. So what you have to do is actually go to the App Store, the Autodesk App Store, to download this. And once you install that, you get a plugin that will basically connect Maya to this application. And I'll just kind of talk over this. This is a video that was created by the lead designer on this project, Lena Lee. That's her there. Not only did she design the user interface and the UI associated with Create VR, but she created some amazing demos. She's a great concept artist as well. And this is showing her kind of in action, creating a concept from scratch, using a reference image as kind of a background. And these are basically just curves. She's dropping down curves, and then in an immersive kind of space, she's able to navigate around those curves. That look like brush strokes, but they're actually represented as curves. She can move them, manipulate them after the fact. She creates them gesturally, but then kind of modifies them after that to kind of reform them and reshape them. But just to kind of go over some of the highlights, again, this is a sidecar application, so it doesn't load up, directly in Maya. You do have to have a VR headset. You have to have something like a Vive or an Oculus. But you can also send stuff from Maya to Create VR. So through FBX. Basically, you can export data geometry out of Maya, including curves, including NURBs, including polys or sub-D polys, and then those can be loaded into Create VR. And then vice versa, you can actually start from scratch and Create VR. You can create curves and geometry, and then you can send that back to Maya. So there are simple tools. I'll show a demo here in a second that actually shows the interface in action, but they're just simple curve and surface tools just built right into the heads-up display of the UI. And then, like I said, you can kind of explore the form, explore the shape while you're in VR, and then ultimately you can end there if you want to and just generate images, or you can actually send that geometry back to Maya. So I'm going to play a quick video here that shows it in action. Once you download and install the app, it will basically piggyback on top of Maya 2020. So you'll get a menu is what I was trying to say, that will connect to Create VR. And then you go to town, basically. You start freeform drawing curves. So if you want to work in a more conceptual kind of gestural way, you can just start dropping down these curves. And then, like I said, you've got curve tools to then manipulate them. And she's showing a couple of different examples here with the dragon and the girl's head, but you can also do more hard surface type stuff as well as the freeform type stuff. We'll show some examples of that in a bit. But once you drop down your curves or your strokes, then you can start to manipulate them with other tools. So you've got these nice kind of pre-selection highlighting features built in, so you can easily see like where your subcomponents are. So, unlike in Maya, you're not constantly having to convert back and forth between object type and component type. You actually kind of have the component type built in with this kind of pre-selection highlighting. You can use reference images, so you can create these images somewhere else, in 2D, and then bring those in as equivalent of image planes that you would have like in Maya, and then start to build and construct geometry from that. So once you get your curves laid out, then you can actually generate geometry from the curves. So we've got basic extrusion and things like stitching and merging tools built into this. So here we're basically taking the gestural curves that were created and then extruding out the body of the camera in order to create the actual geometry of the shape. So you're constructing in this kind of VR space. Like I said, it's fully immersive, and you're basically just exploring with shape and form, and then you get these heads-up displays that pop up that allow you to access the different tools. And so you kind of just stay in this flow. You kind of just continue to work without being interrupted by like necessarily having to switch between tools, because a lot of the tools are kind of built into this kind of one workflow. So you could do things like extrude and stitch your edges and manipulate your edge loops and manipulate your vertices, all kind of in the same context. It's similar to bringing in reference images. You can bring in reference geometry as well. So here's a piece of geometry that could have been created in Maya, or it could have come from somewhere else. Through FBX, you can load that into Create VR, and then you can build on top of it. So you can snap your curves and snap your other objects on top of that. And then, like I mentioned, also it does support sub-Ds. So these are poly-based sub-Ds essentially. So you could create a cage in Maya and send it in, or you could just build the cage from scratch. And then you get these cool pre-selection kind of highlights of the sub-D edges, where you can then apply creasing and hard edges. So you can, by default, of course, have these rounded, smooth edges that you would expect with the sub-D, but you can crease that at any point at the vertex or the edge level. And then as far as manipulating, I already mentioned this, but you've got these cool pre-selection ways, highlights for your vertices and your edges. You've got quick menus that are associated with the controllers. So you have your controllers, and then you can pop up these context-sensitive menus that allow you to quickly activate different features. And then ultimately, like I mentioned again, you can export this all back to Maya. So here's an example of a shape that was completely started from scratch in Create VR that was then ultimately exported into Maya for finaling or for rendering or for animation or whatever you're going to do with it. Again, you go to the App Store to download this. Actually, if you just go to the Autodesk App Store and just go to the Maya section, there's a little link for Maya at the top. This should be the top app that you'll see. And then, of course, there's full documentation that explains how to use it. That's really in-depth and detailed. These are just a few examples of some things that can be created. Like I said, it's pretty wide range. You can create hard surface objects. You can create more gestural kind of freeform objects. You can create realistic. You can create more cartoony. A pretty wide range of different types of objects you can create in here. So with that said, I'm going to go into some additional modeling improvements. And this is where we get into kind of some lower level, more granular things. There's a lot of little things that aren't necessarily related. Some are related, some aren't, but things that are useful from a modeling perspective. Now, this first one that we're going to talk about is targeted specifically for game asset artists, people who are building assets for games, and they want to see those kind of the the budget count, the polygon budget count that they're going to deal with in Maya before they ever get to Unreal or to Unity. So it's called the Game Vertex Count HUD. Uh, HUD, for those of you that don't know, stands for Heads Up Display. It's just a quick way of saying it, but it basically gives you information in the viewport. So for this one, I'm going to also stop talking and just play a pre-recorded movie just to kind of walk you through how this works and why you would need it. In previous versions of Maya, it could be challenging for game artists to predictably meet their game asset budgets based on the vertex count in Maya, which is often used as a metric for game assets. So what you'll see here is the triangle set, or rather the vertex setting under the standard polycount heads-up display says that there are 20,000 in my scene. This is a couple of different meshes, but altogether this object is around 20,000 vertices, or so Maya says. However, when we take this into a game engine like Unreal or Unity, we're quite likely to get very different results. So we have created a game vertex count HUD that will give you a much more accurate representation of the vertex information. So what you can see here is that when I enable that, now my vertex count goes up to 41,000, a little over 41,000, from 20,000 to 41,000. So as you can see, the discrepancy can be quite dramatic. Now, in addition to that, we have also added evaluators for different game engines. So we have the default kind of simple evaluator, which is just general purpose. But if you're exporting to Unreal or Unity, we also have evaluators for both of these. And these will be slightly different based on a few settings, such as tangent mode, as well as some normal settings. This includes settings for MICT tangents for both. But if I apply this now, you can see that my Unity game for text count is 34,000. If I switch this to Unreal and apply now, my game for text count is very similar, but it adjusted slightly. So just depending on various subtleties with your geometry and the target engine, you will get different results. But either way, this will give you a much more accurate representation of your vertex count in order to budget your game assets. To make it a little more clear about what's actually going on here, I've set up a very simple example. You can see I've got a simple surface that is basically made up of 3 by 3 or essentially 9 faces, which equates in Maya to 16 vertices. So a vertice for every intersecting point you see here, which makes sense. However, depending on the geometry, this could change with different situations. So for instance, if I were going to grab this edge and convert this into a hard edge, what you'll notice is it actually splits the vertex normal at each of those locations and essentially doubles the vertex count. So now you can see that even though Maya is still seeing this as 16 physical vertices, the game vertex count is actually 20 because it's taking into account those split vertices. Another example would be with UV editing. So you'll see here I have a single UV shell. So if I take this larger shell and I scale it down a little bit, and I'll move it off to the side, and then I take a single face within this and I simply unitize that, which will basically separate that out into its own unique separate UV shell. As soon as I did that, what you can see is the vertex count went up again because of the UV borders. So the UV borders in conjunction with things like hard and soft edges can really have a big impact on the game vertex count that you should expect to see coming out of Maya. And again, with the game vertex count display, you can now get a much better approximation or calculation of what your vertex count is going to be when you send it to a game engine. So again, this was a real pain for game artists in the past because they'd have to actually send it to the engine to get any idea of what their actual count was. And now, of course, you can just do that on the front end in Maya a lot more easily without having to go back and forth. So we're going to talk about a few other kind of low-level changes. We've got a few related topics or a few related updates, I should say, around pivots and transforms. And it's not the most glamorous thing to talk about. I mean, pivots and transforms are kind of boring, frankly, but they're important because it's something you touch literally, every day. So one example is interactive pivot snapping. So we introduced interactive pivot snapping where you can go into this interactive mode and snap to different points. but it was super limited because you could only snap to the points on the object you were working with. Now you can actually snap that interactive pivot to anything in your scene. So we've opened it up so that any object that's visible in your scene, you can align or snap to the vertices or the edges or the faces. You can control just the orientation or just the position and so on, all the stuff that you would expect, but now it's going to work with all of the different assets in your scene without having to constantly juggle your selections. So little change, but one of those things you do pretty frequently. Uh, Another update to transforms and pivots in particular is the bake pivot option. So in the past, when you went into interactive pivot mode and you edited that pivot, it would temporarily set the pivot. But if you went back to object mode, it would basically lose that offset. So now you can actually set it to bake. There's just a simple setting on the transform tools where if you rotate that pivot, for instance, it'll automatically bake that rotation of the pivot to the underlying transform under the hood so that you don't have to constantly go back and forth and reset it. So that's optional. You can turn it off if you don't need it, but oftentimes you obviously would. Another thing that we've updated is match transforms. So match transforms, it's been around for a while, but it used to be kind of an all or nothing proposition. You could match X, Y, Z, and that was it. Like you couldn't control the individual axes. Now you can match just X or just Y or just Z or some combination of them. So if you just need to match the height of a transform or you just need to match left to right or whatever. This is applicable to modeling, but also things like rigging. If you need to align things like controllers to a skeleton or something like that, you can obviously use it for non-modeling purposes. Another option that we've added for matching transforms is the bounding box scale match, which is super cool because it's a simple little thing, but it allows you to match the scale of an object independent of its actual transform values. So in a lot of cases, if you set scale to be 222, then it's not going to be the same for each object. I'll actually let this one play again, but as you can see here, each one of these has a different scale kind of relative value. So if you set them to 0.5 or 2, then they're not going to scale the same way. Here we can go into match scaling, set it to bounding box, and we can have these match the exact scale regardless of what their underlying scale values are. So again, little change, but super useful when you need it. This is something that has been kind of a long-running request on the modeling front, and that is the ability to add thickness to an object. So Max has been able to do this very well for a while, and we basically just needed to go in and rewrite some old code, is what it boiled down to. So we went in and we basically rewrote the extrude thickness algorithm to allow it to work on a complete shell that is of complex kind of structure and shape. So what you can see here is in Maya 2020, if we extruded on an entire object, depending on the shape of that object, you'd get these wacky results. So it wasn't really easy to do and it would require a lot of fixing. Now in Maya 2022, it just works. So when you extrude on an entire object, just because you want to add a little bit of thickness to that object, now it extrudes in a very predictable, very uniform, very even way. So there's nothing you have to do. You don't have to change any settings. It just works now in a way that it didn't work before, as simple as that. But it's, again, this is one of those things that people are confronted with on a pretty regular basis when it comes to modeling. So one more improvement, actually, we've got a couple more. Faster selection, basically. We've actually improved low-level selection kind of across the board, but it shows up particularly well around lasso select, which you use oftentimes when you're dealing with like scan data. So if you have really, really high resolution scan data in the millions of polys, you sometimes need to isolate parts of the geometry. So it's almost embarrassing to show this, but in Maya 2020, this actually took really long time to do. This is an almost, let's say, 7.5 billion poly mesh. You can see in 2020, it's still going, and I accelerated the time. So it actually took almost a minute to select the head on this object in Maya 2020. Again, not great. But in Maya 2022, that same exact scene, you select the head, and a second later, it's selecting. So this is what you would expect. Again, this is one of those cases where we had old code that we basically just need to go in and refactor. So we went from, again, a minute down to about 1.5 seconds, so whatever that is, 45 times faster, if I did my math right. Target weld has improved to incorporate preserve UVs. So on the UV front, you've been able to preserve UVs when you manipulate a vertice or when you move edges around for a while. But there's some tools that just didn't support that, and target weld was one of those. So now when you target weld and your stitching between like different shells, it'll actually merge those. It doesn't even have to be shells, but let's say a hole or something, and it will kind of recalibrate the UVs under the hood. So it will actually correct the UVs to avoid texture stretching or texture distortion, or at least minimize it as much as possible. And that's just a setting basically on the tool. On the UV front, also, we've made a few incremental improvements to the UV editor. So common request was, hey, we need feedback on the UV coordinates and be able to track those easily. So we added a UV heads-up display so you can actually see the UV values. And then also from an editing standpoint, when we introduced the UV toolkit, we actually lost the ability to directly edit the UV values. We've added that back in, so now you can go back in and you can select one UV and you can edit either U or V or both, and or you can apply that to multiple UVs if you need to do like an alignment, or if you needed to kind of copy and paste values around between UVs. So very low level, kind of simple change, but if you're doing UVing a lot, that's obviously gonna be a factor. And then lastly, we want to talk about some updates to the Paint Vertex Color tool. Again, this is kind of low level, but if you're using Vertex Color to store data, which is often done with game development, like oftentimes you'll use the RGB channels to store some sort of a game data that you would then use in game for some other purpose. You couldn't really visualize that before. So if you were going in and you were painting R on one part, red on one part and green on another part and blue on another part, you couldn't really tell because it would always show you RGB. Now, if you look below here in the display settings, we have channels R, G, and B, and we can toggle those on and off so that you can see exactly where your R is, exactly where your green is, and exactly where your blue is, so you know where that data lives and how it's applied. And then one last thing, it doesn't show up in the demo, but some people are using alpha also to store data. This is a simple channel. And so now we have the ability to represent that alpha as actual alpha, in other words, actual transparency, or you can toggle into this grayscale mode so that you can actually see it kind of as a grayscale value if you're using it for other purposes. So those are some nice, again, kind of low level improvements, but if you're doing this kind of work, then obviously it's gonna have an impact.